I like that. Congratulations. I don't know what you did, but it sounds awesome. Hello, everybody. Let's get started. Just as a quick reminder, I'm sure you're already aware, but just as a reminder, you do have 2 more assignments due on Sunday for the chapters that we've done this week. That would be chapters 5 and 6, I think, is correct. There's actually no studio today, so you'll have some time in class after this to work on those and get all caught up. So we can have a chat about that in a little bit. I think that's all the reminders that I have for you. Any questions about upcoming logistical stuff before we hop into material today? So we hop into content? All right, fantastic. Well, this week we introduced decision making, and in fact, I want to, before we begin, I actually want to congratulate you all on reaching a very important milestone that you may or may not have realized that you've met. At this point, we know variables and functions and loops and if statements, and with those 4 things, actually, you can write any program that could possibly be written with just those 4 tools. So you already have the skills to write any program you could possibly want to write. So we're just going to stop class now, and you guys can go off and get busy, right? Why do we even do this for 20 weeks? No. I mean, obviously, there's still more to learn. Just because you could write any program you want with those 4 tools doesn't mean that it would be an easy process. There are still lots of other tools out there that will make writing programs a lot easier for you and everybody else involved as well. So there's still lots more to learn, but I do think it's good for you to realize that that's kind of amazing fact. If this had been, back in the 1960s or 1970s, this class probably would be about over by now. That's about what they had. They didn't have much else available to them at that time. So, but we got a long ways to go. So let's talk about things like comparison operators. What's a comparison operator? Somebody give me an example of a comparison operator. Equals. So we need to be a little careful, right? Equals, single equals, is what? Assignment. So when I want the comparison operator, I'm talking about double equals, equal equals. And if you haven't done so already, you'll mix the 2 up. I promise you will. I will too. It happens to all of us. But you'll get used to it as time goes on. So we do that when we want to see if 2 values are the same, right? 2 values are equal to each other. What else we got? I'm sorry, what did you say? Less than. Good one. Yeah. Not equals. Yeah, so how do we say not equals? Exclamation point. Yeah, exclamation point equals. Less than is just we call that an angle bracket. And then greater than being the other angle bracket. And then greater than, equal to, less than, equal to. I believe that covers it for the most part. Might be forgetting 1 or 2, but that's most of them. What's a logical operator? And, or, not. Those are the big 3, actually. There are others. You're not likely to see them very often. You're going to see and, or, and not very frequently, though. In fact, I'm not a big fan of telling people to memorize things. Like, I'm just not one of those teachers. It's just like, memorize every single thing that you read. But and, or, not are things that you should probably just go ahead and memorize. You're going to use them so often. And in the textbook, you saw those tables. We call those truth tables. There's only 4 possible outcomes for and or, and there's only 2 possible outcomes for not, right? So it's good to get used to those because we're going to be using them quite frequently with the next topic on our list here, which is an if statement. What does an if statement need to do its job? It needs the word if. It needs a condition. So what can we say about that condition? What has to be true about that condition for it to be a valid if condition? Has to be true or false, or we have another word for that, a Boolean. The condition has to evaluate to be some kind of a Boolean value. So I have to look at that condition, and I have to say thumbs up or thumbs down, right? Yes or no. It works or it doesn't. So that's where our comparison operators and our logical operators are going to come into play. Because when I use those, the result of comparing two values is a yes or no question. I say 7 double equals 3, and you say false, right? I say 4 is greater than -1, and you say true, right? Those are the kinds of things that you're going to see being used with if statements. And so then once I have the if and the keyword, right, then I have the body of the if statement. The body of the if statement is actually an example of something we talked about last Monday in class. We saw it with for loops and functions as well. Anybody know what I'm getting at? I'm opening a new, I'm sorry? Scope. Yeah, that's right. I'm opening a new scope. How do I know I'm opening a new scope? Indentation. Indentation tells you that you're opening a new scope. So any variables then that I declare inside of an if statement, any variables that I'm creating inside of that if statement, can only be used inside of that if statement. I cannot use them outside of that if statement. If I want to use variables outside of an if statement, I have to create them outside of the if statement first. That's how scope works. And so if allows us to make decisions. I now have a choice that I can make based on information. And not just one choice necessarily, but perhaps lots of choices to make. So what's the difference between else and else if? What's the difference?
One else.
I can only have one else. I can have a lot of else ifs. There's more differences though. We can talk about this in a little more detail, right? Yeah, in the back. Else if requires another condition. I'm specifying another condition with else if. Whereas else is always going to show up at the end, right? Else is basically like, well, nothing else that I asked you about worked, so just do this. Do I have to have an else? No, I don't have to. Do I have to have an else if? No, not necessarily, right? I can just use if by itself, or I can tack on else ifs and elses as well. It really is, so I mean, if you're thinking about how to write if statements, how to code these things up appropriately, it's really just a matter of, we would say we're identifying the different cases. How many different potential paths are there to take, right? Figure out the conditions. If these particular conditions are met, I want to take this path. If these particular conditions are met, I want to take this path. These particular conditions are met, I'm going to take this path. If none of those conditions are met, I'm going to take this path in the else statement. Cool. I had another question, but I kind of forgot what it was. So I guess I'll pause and see if you have any questions for me so far. Yeah, in the back.
When do you choose to use an else in your conditional statement versus letting your control flow? Like, so when do you choose to use an else versus when you choose to not use an else, and just let the line of execution move on to the next line?
Okay, great question. So the question was, when do you choose to use an else versus when do you choose to just leave an else off and let execution just go to the next line? So subtle differences between those two, right? If I have an if statement and an else statement attached, how many of those options, there's two options there, right? How many of those options am I going to do? One or the other. It's always exactly one, right? Exactly one of those options will always be chosen, either the if or the else. If I just have an if with no else, right? How many of those options? I have one option now. How many could I possibly do? I might do one, but I might not do that one either, right? I could just skip it, and then anything that comes after the if is going to be done every single time. Every single time. You do need to be a little bit careful and consider that, especially if you're using else ifs and chaining a whole bunch of things together, right? This will happen sometimes actually, where I'll list out multiple conditions, and maybe there's more than one condition that actually works. that actually resolves to be true, but I'm still only going to do one of those options, whichever one comes first on the list. So it is important to think about the order that you specify those conditions. Typically, we want the most specific conditions to happen first, and then just generally get more and more broad as we go along, and then the else statement is like the broadest one of all. Anything else that doesn't work, just do this instead. But yeah, if I write an if statement, I'm always going to take an if statement with some else's involved. I'm going to take exactly one path, or potentially 0 if I don't have an else on the end. Great question. Other question?
So the computer's just going to know that the if statement is completed based on indentation if you don't have an ls or an else?
That's true, yeah. The question is, we know how do we know the if statement's over? It's all based on indentation. As soon as you stop indenting lines, you are no longer inside of the if statement. That is correct. Yep. That's how Python does things. Same with loops. I know the loop's over when the indentation stops. Now where things can get a little tricky, and you saw some of this in the textbook too, right? I can have an if statement inside of an if statement. That's definitely possible. I like to call that a little ifception. I don't know, going way back. That movie actually came out longer ago than I want to think about. I first started telling that joke, when that movie came out, and everybody laughed, and now every year it just gets a little bit less. I don't know. It's still a good movie. It holds up well. Anyway, I can put if statements inside of if statements, and it does what you would expect, right? The second if statement is going to be indented even more than the first one is. So I can stop that one and still be inside of the first one. That is possible. Same thing with loops. I can put loops inside of loops, and it's all based around indentation. In fact, I have an example coming up showing exactly that. Any more questions about if statements? Let's take a look at a loop example. I know loops weren't on the topic for today, but I did want to go through a quick loop example because we're going to start to see more and more stuff that looks like this coming up. Here I've got 2 loops, and I've got one loop inside of another loop. And I can tell that because it's of the indentation, right? That second loop is inside of the first loop. So my question to you is this. How many times am I going to see the word yo show up? 10. That's the easier one. The second question is a little bit trickier. How many times am I going to see the word low show up? 200. How did you get that? 10 times 20. All right, let's take this a step farther. What order is it going to show up in? How am I going to see those show up in order? Yo followed by 20 lows, right? And then another yo followed by 20 more. And then another yo followed by 20 more until I'm done. Until you're finished, until you get through all 10. This is actually a very common construct. We're going to see this loop inside of a loop happen a lot more often from here on out. We're going to see if statements follow this structure as well. If statements inside of if statements, loops inside of if statements, right? If statements inside of loops, the whole deal. We're going to see it all coming up. So it's important to understand that these tools are very flexible. I'm not just using one loop, I'm using a lot of loops, and I'm mixing and matching and combining them together as appropriate. Are there any questions about this before we do a little code practice? So I want to do a little bit of a walkthrough. It's not on the official quote-unquote agenda, but I have the microphone, so we're going to do it. There was actually a bonus mission that got quite a bit of discussion on Slack last time that was on the end of the last studio that I wanted to talk to you about, the Fibonacci sequence. Some people were talking about it on Slack. It's one of my all-time favorite problems. And so we can actually incorporate some of today's material into that problem as well. So I'd like to just take a look at that and see if we can work on a solution to this problem together. So here's the Fibonacci sequence. It's a very famous sequence. Starts with 0 and 1, and then to get the next value in the sequence, I look at the 2 previous values and I add them together. So 0 plus 1 gives me 1, 1 plus 1 gives me 2, 1 plus 2 gives me 3, etc., etc., etc. So I want to write a function where I plug in a number n. And I want that to give me the nth number of the series. So if n is 2, this is actually number 0, 1, 2, it would give me this one. If I asked for the second number in the series. Fib of 2 would be 1. Right? Fib of 3, 4, 5 would be 5. Okay? So let's think about this. I want to code this up. It's going to use actually everything that we've discussed so far. We're going to have functions. We're going to have variables. We're going to have some other stuff. In fact, that's the first thing we should talk about. Anytime I approach a problem like this, I want to think, all right, what are the tools that I have available to me in my toolbox that I think might help me out? And maybe try to come up with a rough outline of the problem. We called that pseudocoding last time. So can we come up with a little bit of a pseudocode solution to this problem? Explain this, what we think the solution is going to be in English, and then go back and take that English and turn it into Python, computer language. So we need a function, right? What should the input of the function be? It's kind of obvious based on the description. Some value n, where I expect n to be an integer, but not just any integer, right? Should be positive. Should be a positive integer. All right. So create a function fib that takes a positive integer n. Okay? Now, I want to draw your attention to the first couple of values in the series, because these are worthy of a little bit of a special attention, right? The series works by adding the 2 previous values to get me to the next value. Well, if I start with this one, right, there aren't 2 previous values. There are no 2 values that I can add together to get that. So actually, the first 2, this 0 and this 1, we don't have to do any addition to get them. They just are, right? That's just what they are. If I ask for the 0 value or the 1 value, I just tell you what the answer is. There's no addition to perform. They are just given. They are just part of the series. And so how could I incorporate that into my code? What would I use? What tool from my toolbox would help me figure that out? An if statement. An if statement. You might have heard me say it just now when I was describing the problem, right? I think I literally used the word if just now describing that problem. Let's talk about this. If what? I'm sorry? If n is greater than 2, ooh, I like the direction that we're going in. This isn't what I was expecting, but it's a good one. If n is greater than 2, then I've got more work to do. What if n is not greater than 2? What do we do then? If n is not greater than 2, so if n is less than 2, then I can just tell them what the number is, right? I can just tell them what these 2 numbers are. So you can approach it from either direction. If n is greater than 2, then we have to, right, do some addition. It's more to it than that. I want to clean that out a little bit more. Else, what? How many potential options are we dealing with here? I've got n greater than 2. Is it enough to say n less than 2? Or do we have to be more specific than that? More specific. Has to be positive still. And actually, so how many possible options are there? Either n is greater than 2 or n is what? It's less than or equal to 2, but we don't want it to be negative. So that only really leaves us with 2 values, 0 and 1. So if n is 1, then what do I want to do? If n is 1, answer is 1, right? Else if n is 0, answer is 0. And now, do you see what I've done here? I've listed out the 3 cases that I know. 0, 1, and greater than, is it greater than 2, actually? Or equal than 2, right? Or we could say greater than 1, same thing, right? But there's one other case, which is if n is less than 0. That's a problem for us. I would call that an error. So what should we do in that case? We should maybe print out some kind of a message, be like, hey, you screwed up. You messed this one up. You can't do this for negative values. So what would I use here? Would I use an else if? I actually don't need the else if. Just else is fine. If n is not greater than 1, if n is not 1, if n is not 0, then what does it have to be? It has to be less than 0. There's nothing else that it could be. I've covered all the other conditions, so an else statement is enough. We say that's an implied condition. Implied condition that n is less than 0 if I get here. It's implied. I don't have to say it, although I just did. I just typed it out. But it's implied that that's what the condition is. So I'll say, you screwed up. Right? You messed that one up. All right, but let's back up a second. If we get to this first one, do some addition is not enough. There's a little bit more going on than just saying do some addition, right? There's a little bit more than that. So let's talk about this part. This is where sort of the meat of this particular function is going to go. I need to set up that pattern where I add the two values together to get me the next value in the series. But I'm going to have to do this how many times? Once? No? N times. So more than once, right? So what does that tell us that we have to do? Some kind of a loop, right? Some kind of a loop. So, loop up to n times, right? And inside of that loop, what am I going to do? I'm going to add those two values together. That's going to get me the next value, right? But this is where the tricky part comes in. So I do that once. What needs to happen the next time around? I'm adding two different values together, right? So we kind of need to shift our perspective. There's like a little window in the series. I like to picture it as a little window, right? If I'm getting this number, my window is here on these two. So those are the numbers that I'm focusing on, right? So after I compute that, then I'm trying to compute this number, and my window is here. So every time we go through the loop, what needs to happen? I need to add the two numbers together. That's going to give me the next value. And then I need to shift that window over so that I'm ready to compute the next value in the series the next time I go through the loop. Does that make sense? Now the tricky part is how do we say that in code? That's the fun part of this exercise. What do we need to add to this function to help us out with that? We need some kind of, so I heard somebody say accumulator. It's not quite the accumulator pattern, but it's very close. I can see why you would say that. It is very close to the accumulator pattern. It's not quite the accumulator pattern. But we do need some help in the form of what? A list? A list could help us, but we officially have not seen lists yet. And actually, we don't need one to solve this problem. It's not required. I'm sorry? We'll need range eventually, probably. What I'm looking for is variables. Yeah, we're going to need some variables. Some variables to track where we're at in this window, right? How many values am I dealing with at any one time? 3. So let's make 3 variables. 2 of those variables are going to represent the 2 values that come ahead, right? I'll add those together to give me the third value. So let's make 3 values, 3 variables. Notice I'm creating them outside of the if statement so that they'll work inside of the if statement appropriately. So I'm going to create, start variable. Let's call it. Let's give it a name. What's a good name for these? Start series 1 at. So what should we start these at? We should start these at the first 2 that we know, right? 0 and 1. So we'll start series 1 at 0. Start series 2 at 1. There's the first two numbers of the series, right? I need a third variable, start next value at what? Does it matter? I mean, we could add them together, right, if we wanted to. Okay, and now we're ready to do our loop, kind of, right? Let's think about it. This addition, do we want to do this here? We could do it inside the loop. I think that's probably a better place for it. I just deleted that code because I'm on a Mac. I don't know what I'm doing. It's not funny. Next value is series 1 plus series 2. Okay? So now I've computed the next value, right? And then the next step is to do what? Shift. We need to shift. So right now, series 1 is this number. What should series 1 be the next time around? Series 2. Series 2, that's right.
Series 2 to the value of, set series 1 to the value of 2, or 2 to 1?
Series 1 is now series 2. And then what should series 2 be? Series 2 was this number. What should it be next time?
Whatever you got, your next value.
It should be the next value, right? I'm shifting it over. I'm moving down the series, right? Series 2 is now next value. And then next value we're just going to leave alone because that might be our answer, right? That could be our answer. In fact, how do I know when I'm done? How do I know when I'm finished and I'm ready to tell you what the answer is? When the loop's over. When the loop is over, right? It's run n number of times. I made it to the end. And so now whatever next value is, that's my answer. That's the last value that I computed. That's the last value that I added together, right? That's my answer. So when the loop is over, so how do I say that in my code again? When the loop is over? Like this? Is this okay? I need it outside the loop, which means got to unindent it, but it's still inside the if statement, right? That's okay? This is an example. You can see clearly that I'm going to have multiple return statements in this function. That's okay. It's inside of an if statement. I'm only ever going to hit one. Whichever path I take, I'm only ever going to hit one return statement. So it's okay. It's okay that I have multiple. Be careful. Seeing a return inside of a loop is almost always a red flag. That is almost never what you want to do. If it's inside of an if statement that's inside of a loop, that might be okay, right? But never directly inside of a loop. Do we want to see a return statement? Because it's going to stop the loop before the loop is finished. It's going to end the loop before it's over. All right. We have done a lot of work already. In fact, I think we've actually done the hard part. That's what I like about doing pseudocode is that you don't even necessarily have to worry about all the weird stuff with the code, like do I have the right colons and the right parentheses in the right places. You just type it out in English. You just figure out how to solve the problem first. Get it in English. It's like kind of code, but it's not really code. That's the hard part. And now that we've got the hard part out of the way, now we can actually focus on dotting the I's and crossing the T's and making sure that everything is in a form that the computer can understand. I feel like this is a lot more straightforward. So let's go back to the top and start it out. Let's do it. I'm going to create a function called fib that takes in a positive integer n. Notice that there's nothing on this line that tells me that n is a positive integer, right? We can't stop people from giving us negative numbers. That's not possible. We cannot stop them. All we can do is check for it and tell them that they're being dumb, right? That's all we can do. Okay, we'll make some variables. Series 1 equals 0. Series 2 equals 1. And now I get to write some if statements. In fact, this line is almost exactly what we want. So much for pseudocode. That was actual code except for the colon. This part will take a little bit of work. Loop up to, well, n times. Let me leave that in. For, how do I type this out? I in range n, okay, colon. Now we can fill out the body of the loop, do some arithmetic. Next value equals series 1 plus series 2. Series 1 equals series 2. And series 2 equals next value. Oops, I did a little typo there. All right, this is actually fine as is. Turn next value. Okay, we're chugging right along. We just have to do these else's down here. Else if n equals 1, return 1. Else if n equals 2, oops, not 2, 0, return 0. Ah, thank you. I was waiting on somebody to tell me to switch these to double equals. You guys are just going to let me drive us off a cliff. That's okay. I'm happy to drive us off a cliff. That's how you learn stuff. That's how you learn not to drive off of cliffs. No? I don't know. Depends on how big the cliff is, right? It's a small cliff. That's how you learn not to drive off cliffs. Else you screwed up, so that's as easy as just doing a print. Should give us a positive number. Be a little bit nicer. All right. So we've written some, and so it can be a little bit confusing with the comments in here now, and if you want to strip some of those out just to make it look a little bit clearer, I'm certainly not opposed to that now that we have a program, right? Just so that it's not as confusing with all of those comments in there. But I still don't know if this actually is going to work. You should never write a program and just be like, that's it, we're good. We always got to test it. We always got to test it out. And if we're testing things, we want to try and test it thoroughly, right? So I want to make sure that these work down here. So I want to pass it 1 and 0 and make sure those work. And I want to pass it a negative value, make sure that it does that properly. And then I want to pass it some bigger values and make sure that it does that properly too. Right? So we need to test this thoroughly. Let's do some of the easy stuff first, right? I'll do fib of -3. And if I run this, it should hopefully give me a message that says I screwed up. So I'll run it, and let's see what happens. Uh-oh. Bad input on line 2. Line 2. What happened? Oh, I forgot def. I used the wrong, I used the word fun because, you know, it's just the mood that I'm in today. That's, in all seriousness, that's me being used to writing in a different language and then coming to a class and forgetting that I'm doing things in Python. So these things happen. Let's try it again. Okay, still got an error. Bad input on line 2. No indentation. Good call. I didn't indent any of this stuff, right? None of this stuff was indented. Thankfully, code editors will know that when you select a bunch of text and hit tab, they want you to indent. If you try to do this in a word processor like Microsoft Word, what happens? It replaces all of it with a tab, which is not what you want. Don't write code in Microsoft Word. Don't do it. No. That's not what it's for. Write your resume in Microsoft Word. That's what it's for. Don't write code in Microsoft Word. All right, let's keep trying. Eventually, we'll get closer. Bad input on line 20. All right. We still got an error, but we're making progress. Line 20, it does not like. Why not?
Oh, because you either have to do else and do
Yeah, so, all right, so the suggestion was I either have to do the if part on the next line, which is actually a whole separate if statement. I actually don't like that as much as the alternative. It's bad syntax, right? This is how you do the else if. Elif, it's just a little shorthand. That's the proper way to type it out for those. But you could actually put an else and then move the if part into a separate if statement if you wanted to. I think it's a little cleaner to do it this way. All right. Eventually this thing is gonna run some stuff. Oh wait, that doesn't need to be indented. All right. We're getting closer, I promise. Oh, there we go. All right, we're not out of the woods yet though. That was like the easiest value for us to test, right? Let's try the other ones. Let's try 0 and 1 and just get those out of the way. And then we'll try some of the other ones. 0, whoops. Output is nothing? Why not?
Well, we didn't print anything.
We didn't print anything. We didn't print anything, right? So this function is returning a value. It's giving us the answer, and we're just saying, I don't care. Thanks, but no thanks. I'm full, right? I don't need it. So, we could just print it directly. This is okay. Or if you'd rather see it spelled out, a little bit more explicitly, you could store it to a variable, right? Store that to a variable and then just print out the answer. They'll both get you there. They'll both get you there. All right. 0, all right, that's good. And then if we try 1, I should get 1. All right, there we go. And now we've got, this is the tricky bit. And I know it's really tempting, at least for me anyway. I don't know how you guys feel about it, but I would love to just plug like 1,000 in there and see what happens. But that's not a good idea. I want to put in a value that I can easily check to make sure that it's right. I don't want to sit here and add up 1,000 things. That's, I won't know if that's the right number or not. So let's pick something easy. Let's pick 2, right? Because I know what that should be. It should be 0, 1, 2. It should be a 1. I hope I get a 1. All right, let's try it. Uh-oh. I got a 2. So something's not right, and maybe some of you know what the problem is. Maybe some of you are scratching your heads figuring it out. But let's try another number to see if we can get a pattern going. See if we can see what the pattern is. So 2 gave me 1. If I plug in 3, right? Maybe I'm just like a number ahead. That's what I'm trying to figure out. So let's plug in the next one and see what happens. 3. If this gives me a 2, then who knows what's going on, right? I don't know. Okay, so it gave me a 3. I got the 3. If I plug in a 4, does it give me the 5? Am I actually computing the series correctly? I am. We're computing the series properly. It's giving us the right numbers, but it's not giving them in the right order, basically. Or we're off, right? Fib of 4 should be 3, not 5. We're 1 ahead of where we should be. So what does that tell you? Where should we look? The range of the loop. We put an n here, which feels like a very natural value, but it's actually not right. Why? Because I already coded the first 2 values here. I already put the first 2 in, so I don't need to account for those, right? So if I take 1 away from that, and now I run this, what did I have in there? 4? So fib of 4 should be 3, and it is. Fib of, right? Is that right? Yeah. 0, 1, 2, 3, 4. Yeah, it should be 3. Fib of 5, 6. Fib of 6 should be 8. Check a few more of these. 6 should be 8. And it is. I'm feeling pretty confident that we have a working solution. 7 should be 13. And it is. All right, I'm feeling good. And now we can do the fun part, where we plug in big numbers and see what happens. It grows pretty quickly, as you can imagine. Oh. Is that right? Does anybody know? Yes, sure. I mean, we have no reason to expect that it's not right. It is possible that it's wrong. I'm not going to sit here and figure it out. We've tested it. We've done some tests.
What was the number? What did it start with?
1,000. Oh, it starts with 4346655.
That's actually 1,001.
It's 1,001? Sure about that?
Yeah, so you got like 4346655.
Mm-hmm. Yeah.
Yeah, no, it's 1,001 because you're starting from 0. If you're starting from 1, it'd be 1,000.
But we've checked the other values, so 0, 1, 2, 3 should be 2. I mean, I could.
Starting from 0, starting from 1.
Starting from 0.
Okay. So this is just yeah.
3 is giving me
If
2.
you look at the list of all the terms of Fibonacci sequence, if you use term 0, it's some say term 1 is 0, in which case that'd be 1,001. But if you correct if you're starting, it basically 1 is 1.
1,000 Fibonacci row numbers. They start from 1, not 0, right? Oh man. Was this a good idea? Was this a good idea? That doesn't look right at all. Well, it could be the next one on the list. Wolfram Alpha says it's right. Okay.
What do they say 1,000 is?
Oh, this is actually, so it stops short. This would actually be 999 because this list starts from 1 and we started from 0.
Exactly. That's what I'm saying. So it depends on how you start the list.
So I think it's right, but we can plug in 999 if we want to be sure. Welcome to computer science, where we fight about numbers that don't actually mean anything. Get used to it. 2, 6, 8. Yeah, it's good. It's good.
Yeah. Off by 1.
No, we're not off by 1. We're on target.
One of us, yeah.
We're on target. We hit what I set out to do. We're good. We match the problem specification that's written here, which is what I was coding towards. So we match the spec. We're good. I'm confident. And, I don't know how many zeros I can add onto this thing before it's going to hate me. But, well, it's that many.
Up there, Father, it says, why does this function stop working after that point?
Yeah, so what's the largest value of n that returns a correct Fibonacci number? Why does it stop working? So we run out of time. That's part of it, right? In fact, that really is the answer. But consider this, though. What? Did it just run out of time? What happened? Where did it go? Ran out of time. Yeah, ran out of time. So that's the answer. We just run out of time. But even if you had all the time in the world, right? Consider that numbers, there's no end. They just keep going, right? They're infinite. Is your computer infinite? No. It's a finite amount of space. It can count very high. We've seen that, right? We've seen the large numbers that it can produce. Eventually, you're going to produce numbers that are so large that your computer is just like, okay, you got me, right? I give up. And infinity is actually a value that is in Python. So eventually, it's just going to give up and it's just going to say, you did it. You hit infinity, right? It's not actual infinity because infinity is infinity, and that's a whole thing. But it cannot represent. The point I'm trying to make is we cannot represent every possible number on the computer because it's a finite number of space on the computer and an infinite amount of numbers in the world. That's the point that I'm trying to make. So yeah, a little bit of philosophical computer science for you, if that's your thing. Actually, philosophy and computer science have more overlap than you might expect, and it's a really interesting topic to get into if that's your cup of tea. And if it's not, then you never have to worry about it because your employers aren't going to care about philosophy very much, probably. Any questions? Any questions? I'll happily post this on Slack so you guys can refer to it if you want. Yeah. Why wasn't it an accumulator pattern? So an accumulator pattern, I mean, I guess you could consider it a variation on the accumulator pattern. Accumulator pattern, I make a variable, and then it's called an accumulator because I just keep adding values to that one variable over and over and over and over again. This feels very similar, but I'm actually doing a little bit more than that since I'm shifting numbers around. So very close to the accumulator pattern. Like I said, you could consider it a variation on that pattern, perhaps. Yes?
So if instead of in the loop, instead of saying return next value, you said return series 2, then you could actually eliminate the condition for the other for n is 1. Because
Oh, I see what you're saying. So we can simplify the code a little bit is what he's suggesting. If I return this guy instead, because the loop would run how many times if n was 1? 0 times, and it would give me the correct value. It would give me the proper result. Would it be series 1 or series 2? Yeah, series 2, yeah, my fault. Yeah, which is interesting, right? We wrote a loop that might actually run 0 times in that particular case, and that's okay. If your loop runs 0 times all the time, that's a bad thing. If your loop runs 0 times sometimes, I think that's okay. I think that's all right in certain situations. Great observation. I'm going to put it back, though, so I don't screw up our working solution. Any other questions? Did I see another hand in the back? Yeah.
Is there a reason why we made it a function of the series 1, series 2, rather than a function of the user input value? Subtracting that input value by?
I'm not sure I understand the question. It is a function of n because n dictates how many times the loop iterates.
We could make n an input and just put it at the bottom. Like she's saying, if you want n to be an input that the user put in, is that right?
Oh, you mean just like use the input like this?
I guess it's a function based off of the series 1 and series 2 equaling 0 to 1, adding the user input minus 1 plus the value of the user.
I mean, you certainly could write a function that does that, but it would be a different series. It would not be the Fibonacci series in that case unless you entered a very specific value. I'm not sure. Maybe I'm misunderstanding your question. The Fibonacci series starts with 0 and 1. So any function that's going to define the Fibonacci series is going to have variables that start at 0 and 1.
Okay, so I'm saying if your index in your first number equals 0, then return 0. If it equals 1, then return 1. Else return the input minus index.
Oh, okay. So I see. You're using a concept that we have not discussed, and actually is not on the curriculum, called recursion, where a function calls itself. That's not something that's actually on the curriculum, but it is a very fun topic in computer science if you Google it, right? We can do this all day. It's when a function calls itself, and Fibonacci is a classic case of recursion. I actually think the recursion is less efficient than using the loop because you end up computing some of the Fibonacci values multiple times to solve the problem. But you still can solve it with recursion. That part is absolutely true. I would not have expected you guys to come up with a recursive solution based off of what you've seen in the textbook so far. If you did, awesome. That's really great. But that's not the route that I would have expected most people to take to solve this problem, even though it certainly can be done. Great questions. Any other questions? Yeah.
So our function is returning some value all the time. We don't have any return statement itself.
That's true. Yeah, that's very true. Could it give us an error? Possibly, right? So the question was, we're not actually returning anything here, right? I'm printing something, but I'm not actually returning anything. So what happens then if I type in a negative value? What's answer going to be? Does anybody know? Somebody said a string. Any other guesses? None. Which is Python's way of saying it's like a void. It's not 0, right? 0 actually exists. 0 is a number that exists. It means nothing. None is like the absence of information. It's like a black hole, right? It's not 0, it's just emptiness. There is no value. And so that's what happens if I don't return a value here. If that bothers you, you could put in a return. A lot of times putting in a return of -1 might signify that there was some kind of an error, right? But not always. I mean, in other cases, leaving none here is okay, I think. I think it's fine, actually, for this particular problem. Not to get too out of whack with what we're doing in this class, but in some languages, we would have to put a return here. It would be required of us. Python, though, does not require you to have a return statement in every single part of an if statement. Yes?
To ask the user for the number of times to run
Yeah.
the function, where would you place that?
Where would I put it? So the question was if I wanted to ask the user how many times they wanted to do it, where would I put that? What are the options? I got, I guess, 2 options that I can think of. Yeah.
You can define a main function and put it down there.
Yeah, I mean, I could put it right here, right? N equals input, right? I could put it here and ask for it there. Another place that I could consider putting it is where? I could put it maybe like right up here, right? But I would be careful about this. It's tempting. It's very tempting to maybe do this at the start of your function. But I think it makes your function less flexible because then I cannot use it without that user input. It's not possible. Whereas this way, I can use it either way. I can get user input and plug it into the function, or I can say, no, I don't care what my users think. I'm just going to plug a number into the function and use it, right? It gives me more flexibility that way. So keeping your user input separate from the actual work you're trying to perform is generally a good idea. Not always, but generally. There's always exceptions. Great questions. Any other questions? I see Ryan in the back looking at me like, get off the stage. I think we have another speaker tonight. Is she here? I haven't seen her. Is she behind me or something? Oh, hey. Yeah, Mia is going to come up and chat with you a bit about her launch code experiences for a few minutes. So I'm going to go ahead and turn the mic over to her. Do you need to plug in to the projector? Okay. Let me stop my recording real quick.